Hey everyone, so this module is on solving exponential equations. So we're going to, by the end of this, know how to use exponents and simplify some expressions, and we're going to be solving some exponential equations using the properties of exponents. So the ultimate goal is to solve something like this, where we have an equation, so we're not graphing. So the first thing we need to do is we need to get these bases to be the same. You'll see that this one's 4 and this one's 2. We need to be the same. So what we do is we look for the smallest base that both of them can be raised to powers to. So in this case, 4 can be written as 2 squared. So I'm going to rewrite this first expression on this side as 2 squared raised to the x minus 1 equals 2x plus 5. So now using the properties of exponents, I know that if I'm raising this power to another power, I'm really just multiplying these. So it's going to turn out to be 2 to the 2x minus 2, because I have to distribute, equals 2x plus 5. Now once I have the two bases the same, I know that 2x minus 2 has to be equal to x plus 5, and I can solve the equation from here by subtracting x on both sides and adding 2. I'm going to do 2 steps at once, and I get x equals 7. I have just solved that exponential equation by making sure that those bases are the same. I can go back and check and plug the 7 in, so it would be 4 to the 7 minus 1, which is 4 to the 6th. Should be the same as 2 to the 7 plus 5, which is 2 to the 12th. Well, we already discussed that 4 is really 2 squared, so this turns out to be 2 to the 12th also, and therefore they are equal. The trouble comes when we get something like this. So the first thing you notice that 5 is the base here, and I can rewrite 125 as 5 to the third. So I can rewrite this as 5 to the 2x minus 1 is less than 1 over 5 to the third. Well, the trick with any fractions or any numbers on the bottom of the fraction with exponents, I can rewrite them as a negative exponent. So this right side here can be written as 5 to the negative third. If you remember the properties of exponents, when I'm dividing, I subtract the exponents. So in this case, having the 5 to the third on the bottom, when I subtract it, it would be 5 to the negative third on the top. Now I can use this to get rid of the bases, and I can solve for x. So in this case, x has to be greater than negative 1. So all of these are, again, practice problems. So the number 1 already has the same bases, so you can use those exponents the same. Number 2 has that 4, which you would then rewrite as a 2 squared. And number 3 has this 9 on the bottom, which can be rewritten as 3 to the negative 2 because of the exponent. So please try these. The problem comes when you have multiple things going on. So in this case, 4 and 8. You might think, okay, 4 times 2 is 8, so I can just say it's 4 squared. Well, no, 4 squared is 16. What I look for is a common base. What number raised to a power is both of these numbers? So in this case, number 4 I have to write the 4 as 2 squared, and I have to write the 8 as 2 to the third. So those are common bases. Now I can solve and then solve the equation. For 5, it's the same thing. This is going to be 2 to the third. The 16 is going to be 2 to the fourth. So you have to remember that it's not the numbers that are going into each other, because 8 can go into 16. It's the numbers that can be raised to a power that equal that. So generally 2's are the easiest one. In number 6, you can see 5's are going to pop up. If you see anything with 9's and 27's or 81's, that's the 3's. For extension, we would actually have to ask you to write this function through these points. So we've actually talked about this, that the general form of an equation is y equals a times b to the x. The first step in anything is to take that 0, 3. That, again, is my start value. So if you remember from graphing, that start value is going to be my a. So I can actually jump to 3 times b to the x. This is going to be my a. If you want proof of this, I can say, all right, this is my x, this is my y, the 0 is my x, the 3 is my y, and plug it in. So I would get 3 equals a times b to the 0. Well, b to the 0 is really 1, so a has to be 3. Now what I have to do is I have to use this point right here and follow the same process. So what I would do is I would plug in 81 is my y equals 3 times b to the fourth. Now I divide by 3. So b to the fourth equals 27. To find b, when it's b to the fourth, what I have to do is think about x squared equals 16. Well, in this case, I would take the square root. And I would get x equals plus or minus 4. For this one, it's being raised to the fourth power. So what I'm going to do is I'm actually going to take the fourth root of 27. To get to the fourth root, it's one number times itself 4 times equals 27. On my calculator, normally there is this caret button. But if I hit the second or the control button, depending on what calculator you have, and then hit the caret, it'll come up with a radical that looks like this. And you can plug in 4 and then 27 into the boxes, and I would get b equals 2.28. So therefore, my exponential function is y equals 3 times 2.28 to the x. And that is my extension problem on how to find the equation of that exponential function. The rest of these problems would be for practice. Please come in next class and with these done so that we can discuss and make sure that everyone is solving these the correct way. Thank you.